Hi guys, in this video I'm going to show you how to make a simple Python game in 40 lines of basic Python code. If you like these type of videos or you want to see more, please hit subscribe and hit the like button. Alright, so let's get into it. As you see over here, I've already actually created the game. So in case you just want to go over how it's going to look like, as you can see, it's all extremely basic Python. There's no new concepts that you would be, any concept that you wouldn't be familiar with. And at the end of this entire video, we're going to see a game that looks like this. Okay, so how do we create this? Well, step one, you're going to create a new file. I'm going to call it gametutorial.py. And the way we're going to do this is we're going to show a matrix of stars, and there we're going to leave one blank space in there, which is depicting the position of our snake. So for this tutorial, we're just going to use the size of snake 1. If you would like to see a more advanced tutorial about how we increase the snake size and actually put in puzzles to solve, do let me know. Alright, I don't know why my camera decided to freeze, but let's get into this. So in Python, we can't really create a 2D matrix or a 2D array like we do in other languages such as Java and C, if you're comfortable with those. So we're going to make a list of lists, which is essentially what a 2D array is as well. So let's say we're going to give our matrix 10 rows and 10 columns. Yeah, let's call it that. And let's create a function called create matrix. Okay, so for I in range, your basic simple looping in num rows. So that means actually let me just get into what this means. And so what we're going to do is, for each row we're going to add a star to each of that column, each of the columns in that row. So we have a row of size 10. For the first position in size 10, there's a star, second star, third star, fourth star. And for like this, we're going to do it for each row. So 10 stars in the first row, 10 in the next, 10 in the next, 10 in the next. So we're going to do that by making a calls array, which is basically the columns in each of these rows. So calls.append star. And now once we've created these columns, we're just going to add it to our matrix. So matrix.append calls. So we've created a list of 10 stars, and now we're adding this list of 10 stars to our matrix, and we're doing this 10 times. So we have 100 stars in total, 10 in each row. Okay, and we're just going to create another function called print matrix so that it's easier for us to call this. Same thing for I in range num rows, for j in range num calls, print matrix in the ith and the jth position. And let's just print it and see what we get. First we create it. Yeah. Python 3 game tutorial. Yeah, game tutorial. Oops. Okay, so as you see, we've actually printed 100 stars, but in Python you can do one thing, so basically print adds a new line at the end of its statement. So if you put end is equal to just that empty thing, like empty character, it's just not going to end the line, and we end the line with a print after we've printed that column. So again, and as you see over here, we have a 10 by 10 matrix printed on all stars. Alright. Okay, so another thing you can do is actually, so just to make this game look a little prettier, you could, after in the print matrix function itself, you could put in a clear statement for your terminal, but keeping in mind that this is going to be a simple one, we're just going to make the size of our terminal exactly the same as the size of the matrix. So every time you print, it's like the position of the matrix is not going to change. I'll show you why this is important. Okay, so let's start taking in the user input. So we have, we're just going to run this forever and get in the user input. Now we're just going to use WASD to figure out if it's up, down, left, right. Alright, and I'm just gonna take it in from here. I've already done it. Okay, and I'm going to use a little different logic than what we used earlier. This time we're going to just leave a trail behind, so it emulates more like a game where you have to, let's say, clear out all the stars without falling into a maze or falling into a puzzle. And okay, so let's take in the user, and we've gotten in the user input in imp, and if it's up, if the user input is up, we want to change let me explain this. So if the user input is up, the position of that space needs to go up. So what that means is the row, that means the I position in our create matrix, needs to go one position up. Okay, and if we say left, then that means our jth position needs to go one to the left. So how we'll achieve that is, let's create two variables, x, and let's keep the starting positions as 5. Yeah, and if up, so and matrix of x and y should be equal to space. So I'm actually just going to put this in a function. Let's call it def update matrix, where we get the positions x and y, and we just do matrix x comma y is equal to a space. Okay, and let's say that the update comes in from the user where it's already a space. So if matrix x comma y is equal to a space already, we just say print you lose, else we update. Alright, sure. So now, okay, now we have a up command coming. That means we have a w coming. So we want to move up. So we do update matrix with x minus 1 and y. Why x minus 1? Because our row is moving up. And similarly, if I want to go down, our row will be moving to one more, so going one below what we currently are. And left, we're going to do x comma y plus 1, because our column is moving to the right, and x comma y minus 1. I think that works. And let's see if it works. Okay, so let me just actually fire the update matrix here as well, so that our initial position of 5 comma 5 is also updated. Done. So if you see now, we've gotten a space at 5 comma 5. Let's click W, and let's go left. So as you see, there's a problem over here, because I am directly updating the matrix in the function and not updating those x comma y values. Let me just fix that. It's my bad. So let's always make this x comma y, and we're going to make it x is equal to x minus 1, and let's run it again. And there you have it. We have created this simple puzzle where the aim of our puzzle is to actually create all of these stars into blank spaces. Now another small thing, if we go too much to the right, it's going to give us an error, because we haven't given a exception handled this case where our index has run out of the actual defined size of the matrix. So I'm not going to do it in this video. Actually, I'm not going to do this. If you want to experiment with this, I'm going to leave the GitHub repository to this down below, and you can create a pull request where maybe we start making the maze a little more complex, where stars are in certain positions but not in all. And at first we could just do this randomly, and later we could actually figure out how to do this in a more intelligent way. And other than that, also we're just printing this over here, printing you lose. We aren't exiting the program, we aren't handling this condition. So if I just run it again, and if I do down, and if I overlap it, so we would have printed you lose over here. But the player could still continue the game. So there's two things you can do with this GitHub repository. One is you could add in the exception handling of going out of the list index and coming back to the start. So if we go out from the right, we come back in from the left, and if we go from the down, we come back from the up, and vice versa. And apart from that, once the person loses, maybe we restart the level, so we create the matrix again. And if that's not possible, we could just close the program. Other than that, if they win, if they're able to do this, maybe we increase the matrix size. I think those two things can be done. Apart from that, thank you so much for watching this video. If you liked it, please hit like and subscribe to this channel. And let me know what you guys want to see next, or if you have any doubts with this one. I'm sure I must have messed up somewhere. If you have any questions, please leave it in the comments. Thank you.